Hey guys, welcome. Hi Kamara and Raekwon. Thanks for being on time, guys. We'll get started in a couple minutes here. Share my screen. Morning, Miyaki.
Good morning.
Can you see my screen? Just making sure.
Yes, sir.
We'll get started about 3 minutes, just letting a few more kids get in here. We got 7. Hello, Dallas. Welcome. We missed you yesterday. Morning, Mari and Juan. I see you, Mari. Thank you. We'll do attendance in a second, everybody, but I appreciate it. I don't know what that means, Dallas. Ascended geometrical plane. All right, it's 8:01. We'll start in about 2 minutes here. Let's give a few more people a chance to get in. We got about 20, a little under. All right, one more minute, then we'll get started. So just make sure you have a separate sheet of paper around. It's really all you're going to need for today. We're not going to do a ton of writing, but it might be helpful to have your notebook from yesterday because we're going to review a little from yesterday. All right, so it's 8:03. We're going to start a little earlier today just because I want to make sure we have time to do everything. I think we'll probably end a little earlier today. Not positive. Depends on how things go here. But welcome to Friday. We're going to review a little bit of what we talked about yesterday and do like one more type of problem that we didn't get time to do yesterday. So it's going to be kind of just continued from yesterday. You'll see it's about the same. So our agenda, we'll do a do now and just quickly look at the exit ticket from yesterday. We'll do a quick skill drill just to review, and then just like this part 2 of yesterday's lesson. Then we're going to do an online activity. So here's my reasoning behind this. One, during that survey that I gave you guys for test corrections, I said like, hey, what feedback? How could we make the class better? I think it was Justin, it was someone, said I'd like to try like some online activities, not always just like a lesson. So we're going to do an online activity. Think of it like a science lab, but for math, so like a math lab. Also, the reason I chose to do this, it's Friday. I feel like all these days kind of feel the same, and Fridays don't feel as fun anymore. So I'm trying to make Friday a little more fun. Back when I taught my first teaching job, I was a 4th grade teacher at School 42. And we did like a fun Friday thing. So I'm kind of trying to bring it back. So fun Friday for today, just to have a little different math class. So I think you guys will like it. It's really cool. We'll get there in a second. So yesterday's notes, your classwork was to send me a picture of your notes, and then I'd give you some feedback. Just wanted to see that we're taking good notes. So here's an example of really good equations. I'm not going to call the student out, but this was really neat. Like it's line by line. It looks great. However, if I go back and look at this, I'm not going to know where these equations came from. So I want to shout out Anthony, who did a good job drawing the circles and like where the lines and the arcs were. So if we're doing circle problems, just like with triangles, like draw the circles so you know what the problem looked like. It'll help you when we get back to class. Because if you just have the equations, it's going to be hard to figure out where this came from, and it'll be hard to study from. All right, so that was just my feedback from the notes. And so remember, it's 8:05. To get attendance, you want to hit that chat button and then type your name into the chat. So just everyone take 30 seconds to do that now. Hit the chat button, then type your name. Thank you, guys. Yesterday, there was a few people that didn't type their name, but they were here. So that makes me think like they just turn it on and walk away. Just make sure you're here paying attention. You'll get a lot out of it, I promise. Thanks, Utia, Sydney, I see you guys. Hello, Dallas. That's not your name. All right. So attendance is done. Great. 2 more. There you go. So just some quick expectations. You guys probably know this, but there might be a few new people who are still like getting Chromebooks and getting things figured out at home. So make sure you're on time. We're going to start at 8:05. Next week, we're going to starting at 8 o'clock. Raise your hand if you have a question, and then stay on mute unless I call on you or you have a question. And then just follow the directions because it's going to be like a real class, and that way you get the most learning out of it. To raise your hand, just in case you haven't been here, you want to hit that button at the bottom where it says participants. All the names pop up, and you want to hit raise hand. And then to talk, you could hit unmute me. Usually I unmute people, but just how we talk. All right, so now we're going to start the actual lesson. To get into it quick, there's only a few things we got to review, and then we'll get to the new lab. So I want you to take the next 1 minute to try this do now problem. Actually, I'll give you 90 seconds. Should be quick, just like yesterday. So make sure you try it on a separate sheet of paper. All right, 15 seconds left. All righty. So thanks, Layla. First question of the day, review from yesterday. Raise your hand. What is the equation you would use here and why? So I see 2 hands. There we go. I'm going to call on Jesse. Jesse, what equation did you use?
I said 2 times 27 equals 6y plus 12.
Perfect. Can anyone build on Jesse? Why do we do 2 times 27? Why is it not just 27 equals 6y plus 12? Justin.
You had to do 2 times 27 because it's inscribed, so it's going to be 1/2 the arc.
Perfect. So we got to make that smaller angle bigger and equal to the arc, so we multiply it by 2 when it's inscribed. Good use of the vocab from yesterday. When it's in the center, so if the little angle came to the point O, then we would set them equal because central angles are equal to the arcs. But inscribed, Justin's right, it's 2 times the angle equals the arc, or half the arc equals the angle. So we would get 54 equals 6y plus 12, subtract 12 from both sides. 6y equals 42, divide by 6, y equals 7. I know Nyla already got it, so just raise your hand if you got that correct. On the chat bar, not in real life. I can't see all of you. Nice. So we got at least 8 people here that got it correct. Awesome. So what we're gonna do now is we're gonna look at the exit ticket from yesterday. So the first question was just like that one. It was 81 equals 2x plus 2. And out of the 37 kids in our class, 30 got it right. So that's really good. It looks like we did really good with that. So that do now question looked amazing. There was one person that typed in x equals 80. X is. Just type in the number because Google Classroom won't take like x is something as the answer or x equals. Just type the number and then you'll get it right. 1 second. Thanks, Ari. All right, so then there was part 2 on the exit ticket. And the second question on the exit ticket looked like this. And now, out of the 37 people, only 9 got number 2 correct. So a huge drop off in how many people got this one right. And so that's why I want to go over this one and let you guys try it again to get better at it. Hello, Caitlin and Zuri. So on the exit ticket yesterday, it was this question. And I think it confused everybody because it's a lot of letters and looks really confusing. So I want to give you a strategy if you're looking at a question like this. There's no numbers except for like the 2 and the 1/2. And I think that's confusing. So what I like to do is I pick, just watch, you don't have to write this. It was yesterday's exit ticket. I just pick a number for the arc and the angles, and then I make the math and see which one is right, which is true. So let's just say this arc is 60 degrees. Okay. That means the central angle is also 60 degrees. Those are the same. And Justin just told us the inscribed angle is half of that arc or central angle. So this is 30 degrees. It's a smaller angle. It's farther away. It's a smaller opening. So now, anywhere I look over here and see a W in the middle, that's angle W, I could put a 30 there. Wherever I see the Y's, I could put the 60. So does 30 equal 60? No, that doesn't make sense. That's not true. I'm going to cross that one out. Next up would be W equals 2 times 60. So 30 equals 2 times 60. 2 times 60 is 120. That doesn't work. So no. Next one would be half of 30 equals 60. Half of 30 is 15. So that's not right. So the last one should be right, but let's just double check. So 30 equals 1/2 of 60. Half of 60 is 30. This is the one that's correct. Oh, sorry. This is the one that's correct. So that's why these 9 students got it right that picked D. But does everyone see how this strategy of picking a number, just make up a number that works for you, make it an easy number, don't make it like 32, like that's an annoying number. 60 is nice and easy to divide by 2. Pick something easy, and it makes it a lot better if you just plug in, instead of the letters, you plug in the numbers, and then you can see which one's true. So I think that's the best strategy. We didn't go over it yesterday, so that's why I think a lot of people got it wrong on the exit ticket. So I want you just to look at this one and try it again. It's not in your packet, or it's just on this screen. So stay here. So try this multiple choice again. I'm gonna give you guys 90 seconds. You might have to draw it out. Thirty more seconds. Remember, BC with a little curve over it means the measure of arc BC. So that's that line. All right, so we're gonna do like a class vote. So in class, I make you like raise your fingers, but here we can't do that. So what I'm gonna do instead is you're gonna type in the chat if you got A, B, C, or D. So go to the chat and type in what you got, A, B, C, or D. All right, so it looks way better. On the exit ticket, only 9 people got it right. And right now we're at 100%. Hopefully you guys are just copying whoever writes the first letter. Don't do that, just be honest. But it looks like everyone's getting B, which is correct. So if I filled this one in as 100, you might have chose a different number. I just chose 100. So that means this angle is 100 and this one's 50. So angle BOC, 100 equals half of 100. That doesn't make sense. 50 equals half of 100. B is the one that is correct. You are right. So hopefully that strategy of just put a number in and then you could figure out which one's right will help you guys in the future, because that's a common like test question or regions question. All right. So quick skill drill. We're not going to write this down. We're going to do this verbally. So I'm going to cold call people to see if they get it right. So the first question, the central angle is 120, AOB. What is the arc AB equal to? I'm going to cold call JJ. JJ, what would A to B equal?
A to B would equal probably 120.
Nice. So this is also 120. Good job, JJ. Central angles are equal to the arc. So if it's the center angle, it's equal to that arc. Good job, man. All right, next one. We got FG, this arc, it's got a little arc symbol above it, a little curved line, is 120 degrees. What is angle I? I'm going to call on Jordan Ortiz. Jordan, what do you think this angle I is if the arc's 120?
Is it 90?
It's not 90. Good try. Raise your hand if you think you could help him out. Sorry, Jordan. Juan, what do you think?
It'll be 60
Why?
because you got split in half.
Nice. So this angle is 60 because it's split in half, because when it's on the circle, it's half. Let me just draw a quick picture so you guys can see this. If it was the center angle, that would be 120 from here to here. That's bigger than this. This is smaller. That is a 60-degree angle. All right, one more. And this one's 2 questions. So the last skill drill question. If arc UV is 80, what is angle Y? What is angle W? Raise your hand if you think you got them both. Nice. A lot of hands this time. Great. Liking the participation. I'm going to call on Robert for this one. Robert, what do you think?
I think angle Y is 80 and angle W is 40.
Perfect. So the big takeaway from yesterday, if you weren't here, good job, Robert, is the central angle is equal to the arc. So this one's 40. And then I think about this as it's twice as far away, so it's getting smaller by 2. So divide by 2, this one is 40. I wrote this in the wrong spot, I just noticed. This was 80. So if it's in the center, it's equal to the arc. If it's on the circle, it's half the arc, or half the center angle. So that's what we learned yesterday, in case you weren't here. It's basically we divide by 2, or if we go from this way to this way, we're multiplied by 2. But there was one type of question we didn't get to, and it's just because we ran out of time. In a normal class, you don't have to write down all the circles, so it's a little quicker. So if you wanted to add this one question to your notebook, you can, but I think most of you will be able to get it right away once we go over it. So it's a little confusing, but it combines some things we already learned about. So this question says, in the above diagram of circle A, so the center point's A, so they always name it after the center, arc BC is 5/12 the circumference. So they don't give us a degrees this time, they give us a fraction. This is 5/12 of the circle. Determine the angles. So I need the degrees here. So I gotta turn this 5/12 into a degree. So 5 out of 12 is the part that's filled in. This is 5. The whole circle's 12. So it's 5/12. But I want that to be degrees. So I want to know how many degrees is that out of a whole 360. So this is just like a proportion. 5/12 of the circle is how many degrees out of 360. So if they give you a fraction, like this is the piece of the circumference or a piece of the area, we could just set up a proportion. 5 out of 12 is how much out of the whole circle, and I want degrees. So now I'm going to cross multiply. 12 times x is 12x. Juan, do you have a question, or is this from earlier? Oh, thank you. So 5 times 360 is 1800. 12 times x is 12x. Divide by 12. So this is 150 degrees. So arc BC is 150. So now that we've figured out 150, I got to find these 2 angles, the inscribed angle and the central angle. So I know the central angle is equal. So angle BAC, the central angle is also going to equal 150 because the center equals the arc. And angle BDC This is angle D. This is the inscribed angle. It's on the circle, so it's half the arc, so that is 75. But to figure out the degrees of these angles, I first just had to make my 5/12 into degrees, and I just do that with a proportion. So we didn't get to talk about those problems yesterday, but they're pretty easy, and it's just like one extra step before we get to how many degrees those angles are. So I'm going to have you try one. And it's on the next, or well, it'd be the next page if we were in a packet. Hello, Nevaeh. But try this question. Gonna give you 90 seconds again. You can do it on a separate sheet of paper or in your notes and building on from yesterday, but just this one question. So BC, the arc, is 1/3 the circumference. Determine the central angle and the inscribed angle.
Hello, Mr. Salamano. We're doing this problem.
Yep, we're doing this one. Hi, Nyla. So just give this one a try. That arc is 1/3 the circle, so the first thing you should figure out is how many degrees is 1/3 of a circle. And you can do that with a proportion. Good question. Amari, what's up?
Oh, I had the answer.
Say it again.
Oh, I had the answer.
Oh, okay. Give me 1 second, okay? All right, so let's bring it back. That was our time. Amari's going to tell us how she figured out how many degrees are in this circle. All right, Amari.
Oh, so basically, I had got like 120.
Yes.
Like 120 as 8, and then you get wait, 120 as X, my bad.
Yep.
Then you get like 2.
So what's B
Wait, no.
equal? What's this central angle equal if that arc is 120?
Oh, 120.
Yes, so the central angle 120, good. And what is the inscribed angle if the center and the arc are 120?
60.
Nice. So here's the answer. We just had to make those degrees into, good job, Amari, into, or the 1/3 into degrees. And think about it, 1/3 of the circle, that's 1/3 of the way around. 120 times 3 is 360. So that kind of makes sense. So this proportion works every time. I'm sure some of you figured out 1/3 in your head is 120 around the circle. Like if the fraction was 1/2, probably most of you in your head could say, oh, it's going to be 180 degrees if it's half the circle. So this proportion works every time if you can't do it in your head. So really good job. We've done a couple problems from yesterday, kind of gotten a better understanding of the questions and inscribed and central angles. Now we're going to totally change gears and we're going to do an online activity about circles. So this doesn't have to do with what we were talking about today, central angles, but it does have to do with our first lesson, which was on like area and circumference. So how we're going to get there. I'm going to pause this PowerPoint for a second. Just watch my screen and then you'll be able to do the same thing. So if you go to our Google Classroom, geometry, and there's the stream where I put announcements and classwork. This might be at the bottom of your phone, but you want to hit classwork. Today is 9.02b. We just kind of built on 9.02, Fun Friday. And it has the Zoom link that you guys all clicked. It's got the PDF of all the work and problems today. And the last thing in the bottom left, it says Desmos class activities. So go to classwork and click on that Desmos class activities, then hit join. And then you want to type your name, make sure it's your first name. If you are Nevaeh, make sure you put Nevaeh M or Nevaeh W. I think that's the only repeated name. So just put your name and then click go. And then we'll just pause right here. Just want to make sure everyone gets signed in. There's a few chats.
Mr. Salamano.
It says your screen's too small because you're on your phone.
Yeah, but I just said I'll take my chances. But
Okay.
so we gotta guess how many pennies are in the circle.
Not yet. Don't do anything yet, but yes. If you need the class code, it's right down here. But if you click the link in the Google Classroom, it should take you right there and you can log in. But if you're doing it a different way, here's the code Z7Y space 2YP. We'll all start in a second. I just want to give people a chance to get logged in. Amari, did you have a question? Okay. All right, just hold tight, don't start yet. We got a lot of people in here, awesome. So if you look at my screen, I could see all you guys. So just pause where you are. If you're on your phone, flip back to my screen really quick, just to show you some things. So I could see all you guys and where you're at and what you're doing. And then we're gonna go through these like 9 slides together and try these activities. So the first one, you could go to that first slide on Desmos, the class activity. And we're gonna watch a quick video. So you might be doing this right now. Hit play. They're gonna tell you how many pennies fit in this circle. So you're gonna predict how many pennies would fit in this big circle on the floor. So how many pennies are gonna fit in this big circle? So your prediction, write a number that you think is too low. So I think it's gonna be more than 50. Write a number you think is too high. I'm gonna say it's less than 1,000. And then try your prediction. What do you think should be right in the middle, or what do you think would actually fit in this circle? I don't know, but this is just a prediction, so make a guess. I'm gonna predict 250. I don't know. So everyone try that one. Make a prediction. Right, so Raekwon guessed 150. Jaheim got 100. Maya with 125. Brianna 500. That's the biggest prediction yet. Oh, Anika said 600. All right. So we got some predictions. Now we're going to actually figure out which one is correct. So go to the next page after you made that prediction. So we're going to go on to the next page. So be on page 2. So here's our scatter plot for what people are guessing. So your dot will come up in orange. That's what you guessed, and that's where the rest of the class guessed. So you can see if you guessed lower than the rest of the class, you're in the middle, maybe you guessed higher than the rest of the class. This is just where we're at. All right, so now we're going to go to the next page, so page 3. And we're going to do an experiment or a lab, so we got to collect some data. So if you could flip back to my screen really quick, I'll show you how to do this. But let's say I want to figure out how many pennies fit in when the diameter of this circle is 3 inches. I'm going to just slide in the pennies and see how many I could fit in. Oop, I missed. So we're going to slide some pennies in, take some data. I don't know if I can't get another one in. So with 3, I got 11 pennies. Now you're going to go make your circle bigger or smaller and see how many you get for that one. So if I did 4.4 next, I would see how many pennies I could fit in now. So do that 3 or 4 times. Do at least 3 different circles and fill in the data. And then we'll have a ton of data because we're going to do this as a class. So everyone take 2 minutes to collect some data. You got to do at least 3. So I'll do some too. So if you're stuck, you can watch my screen for a second and see how I'm doing it. Yeah, 25.
Why can't you just keep the 5 pennies in there?
I don't know, it won't fit. So I'm gonna go, I can only fit 4, apparently. I'm trying to get them around so I can jam in there. So try it on your own. You don't have to do the same size circles I did. So we got 27 people taking some collections. Thank you, Honesty. I see Kamaya's already got 3 done. Justin's already on 4. Thank you. Going above and beyond. Mr. Bianchi's getting involved. I like it. All right, finish up the one you're on. 30 more seconds. So you want to get 3 data points. So JJ, try to fit more pennies in that circle. JJ, what happened, man? All right, about 10 more seconds. All right, so if we go to the next screen, we're gonna see something really cool. So go to screen 4. And if you look, this is all the data from everyone in the class. So again, the ones that are highlighted are yours. Everything else is people in our class that took data. So we get a cool looking graph. I'd say there's like 4 at the bottom that don't look right. Something weird happened there. Maybe a student just hit the wrong button. So ignore those 4 at the bottom that are like making a straight line. I don't think those are right. So based on your graph here, your orange data and your classmates' blue data from the previous screen, what kind of function do you think this is? Linear, quadratic, or exponential? So everyone take a guess. Do you think it's a linear function, exponential, or quadratic? And then once you take a guess, you could go to the next screen. So I'm seeing 3 people chose linear, 5 chose quadratic, 11 chose exponential. Okay, a few more for linear. So right now, exponential is winning, linear is in second, quadratic is third. All right, so now when we go to the next page, I think this is the most confusing part. So you want to look at my screen. So wherever you are, look at my screen. Give everyone 10 seconds to get there. So go back to the Zoom call. So the model on the screen is shown in red. The model of this is 11x squared. Your original estimate was 250 pennies. Based on everything in this calculation, how many pennies would fit? Oh, I'm gonna go back to the fourth screen because I wanna make my model. I'm gonna move these points so it looks like it fits the curve better. So go back to screen 4 and make sure your model like fits the curve. So if it's linear, try to make the points go through as many points as possible. If it's quadratic, move these points around so it fits. Exponential, move these around so it fits better. Give everyone like 30 seconds to do that. Sorry, bad directions there. So go back to screen 4. And you want to move your model around. Use those red dots so the line fits it a little better. Quadratic. All right, and then answer that question at the bottom. Why do you think a quadratic model makes sense here? Why do you think a linear model makes sense here? Or why do you think an exponential model makes sense here?
What question? Oh,
Yes, Nyla, go for it.
where?
Where what?
I can't find the question.
So it's at the bottom of page 4, the fourth screen. So if you're on the 5th screen, you're one too far. Sorry about that. All right, we got a few people that answer the question. Make sure you come up with something. It's okay. We're just learning here. It doesn't have to be perfect. So Robert says linear because it's increasing as a steady slope. Brooklyn said exponential because it's growing without stopping. Jaheim says it's increasing by 2, so it's exponential. There we go. The lines are looking better now. Caitlin, you need some help? Caitlin, go back one screen to 4 and make your graph fit there. So like this. All right, these look really good now. So most people got them. There's a few that are stuck, but that's okay. Natural's figuring it out. So now the next screen, we're going to go on to screen number 5. So it gives you an equation. And now we're going to base on our, here, I'm going to read it for you. The model on the screen is showed in red. Here's your equation. So everyone's going to have a different equation. Mine is 1.33x squared. And then it'll tell you your original estimate. So my original estimate was 250. Based on your calculations, make a final calculation. How many pennies will fit in a 22-inch circle? So that is my diameter. So I'm going to figure out y equals, and then I'm going to plug in 22 for x, for whatever my equation is, 1.33. Everyone's going to have a different equation though, times 22 squared. And you're going to use that equation, plug in 22 for your x, and see if you were close to your prediction. So you need a calculator here. So I'm going to do 22 squared So my prediction would give me, so based on your calculation, how many pennies will you get? I would get 644 pennies. Brooklyn, that's right. But actually calculate it in your calculator. So don't type your equation, type in your answer for y. So do 1.67 times 1.815 times 22, Brooklyn. And then you'll get your answer. So I'll give everyone about 1 minute to calculate their final answer. I got 644. And then just stay on screen 5 for a little while. And we'll wait for everyone to figure out their calculations. All right, so we got a bunch of different ones now. Good. See that most people are done. There we go. So then you could see your calculation number and your estimation number. And mine are really far apart. It looks like I underestimated how big or how many pennies were going to fit in that circle. I was a little off based on my calculation, but I don't know if my calculation's right yet. So that's what we're going to do on the next screen. So go to page 6. Actually, we're going to skip this one. It's an extension. I want to skip it. Extension 2, we're going to skip it as well. We're going to go to that final answer. So go to page number 8, and we're gonna watch the video to see how many pennies actually fit on this screen. So it tells you your estimation. Mine was 250, and my calculation was 644. So we'll see what's better, my estimation or calculation. So I'm gonna hit play on that video, see how many pennies actually fit in the circle. All right, so my estimation was too low.
I was pretty close.
You were close.
I had 500. I had 500. I mean, I was close.
You were close. So
Yeah.
my calculation was 644. This is 633. So my calculation was really close. My estimation was way off. So who has a close calculation? Raise your hand if yours is close. So it might be tough to go back to the chat, but I'll just check the screen. So there's a few that are really close, and they tend to be the quadratic people. So the people that chose quadratic, y equals ax squared, seem to be the closest ones, this equation. Thinking about the area of a circle, why does quadratic make more sense than exponential? So look at this equation that I wrote on my screen. So go back to the Zoom call. So everyone come back to the Zoom call for a second. I want to show you something. So when I figured out my equation, I got some number x squared, and that was how I solved for y. Why does that make sense for the area of a circle? Because we're filling in the circle. Why does it make sense for area? Raise your hand if you think you got it. Nice, Kyle. That's really close. Jesse, why do you think this makes sense for area of a circle?
This makes sense for an area of a circle because it's not like it's an irregular shape, so it doesn't have right sides to be able to like calculate something if it was y equals mx plus b, because you don't know like the starting point, you could say, or like the area.
I like it. Jesse, or Brianna, can you build on Jesse? Good start.
No, I really can't. I was
Okay,
raising
I'm gonna ask you a question. What's the area of a circle?
um,
What's the formula?
the formula.
Mm-hmm.
Pi times radius to the
To the what? You're close. Pi times radius what? It's pi times radius squared.
squared. Yeah, my
So
internet connection went off.
It's okay. You froze up. That's okay. It happens. So if we look at what Brianna's saying, area is pi times radius squared. See how this is a squared? So this is an exponential function. Or not an exponential, I'm sorry, a quadratic function. So since it's pi radius squared, that's why the quadratic equation worked the best here. And that's why my accurate or my estimation or calculation was really close to the final answer. You used linear or exponential, you probably would have been a little off. This was not linear or exponential, and it's because the area of a circle is pi r squared. Last thing we're going to look at, just a quick reflection. Page 9. It just asks, with tables, it's easier to blank. With graphs, it's easier to blank. And with equations, it's easier to blank. So we just did that activity. We looked at tables. We looked at some graphs. We looked at some equations. Why was it helpful to look at the tables, or why did we use the tables? Why was the graph helpful? And why was that equation helpful? So you just want to type these, hit share with the class. And then once you do that, you are done for the day, and you can have a great rest of your Friday and a great weekend. So finish that up, and then you are free to go.
So we just gotta like give a reason or something?
Yeah, so give me the reason for number 9. So for example, Jesse said, with tables, it's easier to see the numbers of each circle. Think about why we used the table in the beginning. So if I was answering that question, why did we use the table? Think about science too, like math and science are related. Why would we use a table in the beginning of a science experiment? Anika, when you hit submit, it's going to turn in your whole lab. So I'm just going to look at your lab on Desmos. You don't have to turn anything in on Google Classroom. This website like collects everything. Good question. So
We done?
yeah, you're done. If you finish and hit submit, you are done.
Okay.
Great. But answer the questions first. That's like your exit ticket.
All right. Have a nice
See you,
day.
Nyla. Have a good day. So hopefully you guys had fun with a little different activity. This activity won't be like on a test or quiz. It was just like a fun way to look at area of a circle a little differently. See you, Jesse.
Bye.
See ya. See you, Mari.
Mr. Salamano, what we doing?
What am I doing?
What are we doing?
So once you hit submit on that classroom activity, the last one, page 9, you're done.
Okay.
Thanks, Caitlin. See ya.
Can I leave?
Caitlin already left. Never mind.
Can I leave?
Yep, you're good to go. Once you submit, you're good. I'm just here if anyone has questions. All right, it's almost 9 o'clock, so I'm going to end this so you guys can get to your next class. Have a great Friday, and see you all Monday morning.